Okay, well it's September 4th and me and Yari's been here for about a week and a half. Justin showed up about a day or two before then, and Connor and Aug-Sep was here also before we got here, prepping and setting stuff up, and this has been quite the episode. Special thanks to Yari for all the organizing and cleaning and tackling the shipping container organization and a lot of other miscellaneous jobs around here and helping these guys out on the lines. Special thanks to Aug-Sep for setting up the signal receiver up at the shack. We're able to at least prove that we can at least get the signals online, and we work to a point that's going to be getting reinstalled until I guess we can have the optimum, full analog way with the amplifier and everything that Eric's working on, which will eventually go up there, and there's some other components to that, and also for at least setting up the telluric beacon. It's got a problem right now, but we were at least able to get that running and tested, and we'll see what it takes to get that back online, because that's really for anybody to be able to tune into 1.999 megacycle. And
well, the thing is we want to see, who can pick this thing up, what kind of propagation.
Yeah.
That's the experiment. It's we got the thing on the air. The power is minuscule, unfortunately, but that increases the challenge. So is it just people relatively close by? Will it come in at great distances? It's there to experiment with.
Yeah.
The power will go up at some point, and it will be refined further at some point. But local tests, like I did in my car, like a couple months ago that you videoed, or I think Justin videoed, is we got out pretty far with virtually no receiving antenna at all. So that's what's going on with that. I mean, it will change later. The other transformers will go in. We'll have to get a special FCC license so we don't have to use the ham bands. Can use more convenient frequencies, to do further experiments with. So at any rate, we got to this point, which is an unfathomable amount of labor was executed to get to this point, which is not readily apparent, but getting those tanks unearthed and getting them welded up, and and going out and harvesting the poles out in Blomfield and then putting them up, and that was a massive effort building that thing.
Might as well make a contest out of it. Who's the first person to pick it up outside of the core group, and who can pick it up.
Well, I'm pretty sure
furthest.
Steve McGreevy will be, because he's in this part of the world.
Yeah.
He's the best test right now of how this thing works, because he kind of understands the propagation. He's got enough materials around and what have you. What he's lacking is he does not have one of these coils, and they're, as you can see, they're not easy to make. He has the medium frequency coil, but he doesn't have the higher frequency version. So, but he's the main guy, but he's real difficult to get a hold of. So. But I'm sure he'll be, once this thing's going, he'll be on it. And as far as the Earth signal thing goes, there's a full high fidelity design that's been completed, but we're just going to start off kind of with the bare bones. So the internet, as you pointed out, the internet connection was made. That works. What's up there now, the solar panels have to go in next. There's got to be power to run the equipment. So that's that effort took up a lot of time in this episode of putting the new roof on and the solar panels, and of course the stuff it's all ill-conceived from China. So a half-a-day project turns into half-a-week project. But at any rate, that all went along good. We have all the panels and what have you. So putting the power in's next, and then in the meantime I have to come up with the front-end amplifier, because when you have 9,600 feet of wire in the air in a place where lightning is clobbering everything, you don't hook transistors or digital to that, because it'll be dead. So vacuum tube amplifiers have to go in down there. to process the signal to send back up to the shack, and then it can go on the internet. So probably there's a possibility that there's some kind of temporary thing that we're going to do with the sacrificial unit. And I think when Jeremy, and if he gets to the point that he has the interface thing all built and all that, then we'll just plug this thing in, and it's fairly well protected against the antenna because it's got to go through a repeating coil and then several hundred feet of transmission line and what have you before it gets to the point of reception. So, and there's other things that can be added, and it'll probably work out okay as long as it's in a lightning-free climate situation. But if there's a heavy thunder, summer thunderstorms might clobber it. So I think that would be the next step. So it's conceivable that that in the next round, even without the vacuum tube front end, that we can have the thing in kind of a raw form on the internet 24 hours a day, and should be able to get this Tillard beacon going. So that's been kind of the main focus here, is to get the Tesla coil on the air and get the ionosphere to Earth signal reception on the internet.
And then special thanks to Connor, who's the closest one to Tonopah, and he's been come down here quite a few trips, not just to help with EPD lab stuff, but with some personal stuff with Eric. He's been helping out a lot, and he's been working a lot with Justin out on the shack with the whole structure, the solar stuff, working out on the lines, and special thanks to Justin for coming out and spending as much time as he is on all of this. And it was my first chance to actually go out there and hang out with the poles and cross arms, and that is not easy work, and it's nothing that I want to do. But I was there to have a beer and watch you guys do it.
Absolutely, and document it, which was great.
Yeah. So, anything you want to throw in about this episode, or anything in general, or?
In general, this has been a long time coming. This is a project that Eric and I started. Eric's actually built these facilities in the past, as a lot of people know, and it was 2013, I believe, that Eric and I started again. 2013 was when we received our right-of-way grant, and that's when we began to rebuild the facilities out here. And it's finally, after all this time, we've got things to a point where all the mechanical problems are solved on the line, and we have a robust structure that's standing there connected to our terminal shack. And these other upgrades that we're talking about, those will come in time. But I'm very satisfied that we have something that is, the physical structure of our antenna is totally legit, end to end, and we now have something that we can develop further from there. And we've been talking a little bit here about the challenges with some of the implementation of what to use as the receiver. We've done demonstration with R37 Bravo, which is an analog receiver, and that's what we intend to use, at least in the current incarnation of this build. But as Eric stated, we're also concerned about the lightning damage, potential damage that could happen to that. So we have to develop the system further before we can use that equipment. But we did demonstrate that this round, and we did put those signals with Aug-Sep's analog to digital converter, data logger. That's the piece that I can't solve for. I don't. That's not in my wheelhouse to solve. So we asked Aug-Sep to provide us with something, and he did, and he actually installed that to my satisfaction. It was RF quiet inside of our rack. So there's some more tweaks and improvements that are going to go into that. He's working on those, and it's still a system that's in progress and developing. But I'm very happy that we've gotten it to the place that we were able to get it this session and demonstrate those signals online. Now we can just tune it up from there.
Yeah, I'll point out you brought up the radio interference is this digital equipment and what have you is not compatible with sensitive signal reception. So it's basically, in some cases, it actually operates as what would appear to be a deliberate jamming device when it starts getting into the power grid and all that. The interference generated starts to get on the kilowatt level. So when you're operating with signals that are 1/1,000,000th of a watt, and then you got some China box screaming away with transients and God knows what else that in my day the FCC would have banned completely. It's really difficult to, you have to take these this Chinese stuff and you have to actually build like a barricade between it and the outside world of filters and isolation transformers and shielding, and basically you have to seal every device in like its own metal can to stop it from interfering with the other equipment. And this has been a constant fight with the ham radio transmitter getting into the earth signal receiver, and the difficulties around this type of stuff are extreme. So not only is it flying lightning bolts, but it's little dancing radio tweaks from the Chinese Trojan horse, so we're getting it from both ends.
Yep, and anybody who's involved with radio facilities, remote radio facilities, or FM broadcasting would relate to exactly what Eric just said. I found this on the coast with the FM broadcast station that I built. The whole idea of a leased pair from the phone company or a studio to transmit or link. That's effectively what we're trying to solve for here with this analog to digital converter. The expense of bringing copper wire back to town and the logistics of that is cost prohibitive, and we just can't tackle that at this point. Who knows if we'll ever be able to tackle that. So what we're talking about is basically in FM broadcast world, it would be the studio to transmit or link. We have a remote facility, and how do we get the signals that we're receiving back to some place where they can be analyzed and used? So I had a heck of a time keeping the router. We had an Ethernet router that was in the FM cabinet, and I had a real challenge of keeping that equipment isolated from the RF feed line, but it can be done. That's what we're talking about. And it's, like I said, people who are involved in broadcasting would likely relate to that. So these are problems that can and will be solved in the future.
Well, there's also, when you brought up around the FM radio station, it used to be when you leased a pair from the phone company, your studio to transmitter link was secure. You didn't have to worry about anyone or anything getting into your signal. The phone company was very, very tight on the quality for that type of stuff. And everything's specially marked that, this is a radio station, do not disturb. Then the alternate is you got your own frequency from the FCC called an STL link. And that's basically was a point-to-point microwave system, and that was your frequency. You didn't have to worry about anybody else, being on that frequency. Of course, it could be deliberately jammed, but that wasn't a consideration back in that day because people didn't behave that way. So the studio transmitter link was generally considered secure. Now everything goes on the internet and you don't know what's going to happen. And there's no more, you no longer have secure control of your facilities. So basically what's used now, you see all these little microwave dishes everywhere, these little toy Wi-Fi links, or or whatever. There's no frequency allocation. You don't know what kind of Chinese Trojan horses there is. At all costs, that stuff should be completely avoided and go to the old techniques. So here, fortunately, we have our own utility right-of-ways from the cable TV companies. So getting a link into the building here is really bad refraction. Even a allocated microwave link would be very sketchy because of all the rooftop refractions and power lines, and it's not considered a valid link. So we have to go from the mine, at least we have a special cable that we have several miles of, and we have a right of way to put it on, is to bring that cable from the mine to the building, and then that carries all the necessary data multiplexed and what have you, and it's secure. And then from there, we have our own allocated microwave link, even though we could use the little toy microwave link out there because there wouldn't be much problem with jamming. And then that controls the shack. So that's kind of the final plan. So right now, the first step of getting the line into town, the first basically third of the 1 mile that it would take is there's a line contractor that can get our cable up and get it done right and expediently, and then that will qualify our situation at the mine. We have to have emergency telephone connection there, and we have to have power. So that will get the phone connected to the mine, and that will be that much of the cable getting in the building. So the cost is not extreme. They want $14,000. That's fairly reasonable, and they're waiting to do it. We just need someone to donate $14,000 for that specific project. That's the complication right now.
Well, I'd like to clarify that we're not contradicting ourselves with these statements. We're saying that we're using this, the current cellular data link. We're willing to use that to show the proof of concept, to be able to demonstrate what it is, the facilities that we've built and what their purpose is, so that we can then generate the funds to build it the way that it's intended, make it more robust. So we're having to work with the newer digital technologies, which are, as Eric pointed out, are more susceptible to interference and problems and all that. That's just what we're stuck with as we try to demonstrate proof of concept and raise funds to take it further.
So, I mean, all of these projects obviously cost money. Some of us are volunteering our time and paying some expenses out of our own pocket for, food and gas, lodging, some of these kind of things. Then there's all the materials and, everything else that needs to be paid on top of the building overhead here and everything. So, EPD Laboratories, Inc. is a 501c3 nonprofit based out of Nevada, and it survives by donations. And so on ericpdollar.com, there's a donate link, and if you go there, you can donate by PayPal. There's an option to do a recurring donation. You can do $5 a month, $10 a month or more. Or one-time donations. There's also a mailing address in Spokane. You can write checks or money orders out to EPD Laboratories, Inc. Send them to that address, and I just endorse those and send them to the bank here in Nevada. But those kind of donations are what makes these kind of things possible. And so whatever you're able to give is greatly appreciated, no matter how small or how big the donation is. It all helps. And everybody's able to learn from these projects, including all of us. Every time we come here, and we're working with Eric on a daily basis with this. We're all learning stuff all the time and sharing it too, because all this stuff gets pretty, for the most part, open sourced, through the YouTube videos, the books, videos, presentations, interviews, and everybody in the public can also get involved with these. If you're a radio amateur looking to get involved at whatever amateur, novice level or above, the telluric transmitter's something that you can take part in trying to receive the Earth signals. Eventually, the idea is that multiple people are going to be able to have their own way to monitor these kind of signals at your own location, pipe those into the internet to be part of a growing database, so we can kind of see where what's going on with these signals in different geographical locations. It's been said for a long time, one station you can kind of tell there's certain stuff that's about to maybe happen. With multiple locations, you get 2 locations, you can kind of spatially locate. The more locations that come online, you can get a pretty good picture of exactly what's going to happen. Not just that something will happen, but where, whether it's related to seismic activity or any other type of natural process. And so it's all a work in progress. But these are things you're going to be able to get involved in. Other than that, I don't know. Any final words, or we're going to hit the road? And,
Pretty much covered it.
okay. So Eric's site is ericpdollar.com. Please go to the donate link and pitch in whatever you can. Also, there's another website, epdlabs.org, and there is a link in the main menu bar that says seismic streaming or earth signal streaming or something like that. Just stay tuned to that link, because that's where we're going to be having the streaming.
Isn't there
earth
some
signals coming
recordings
in.
or?
There's a recording right now that's looping.
Oh, so basically, we have a sample.
There's a sample.
Yeah, okay, good.
And then we'll send out a newsletter notice when everything is live. Eric's presentations are available on emediapress.com. In the top right corner, there's a product search, and you can type in Eric Dollard or any of his presentation names, and those will come up. But if you go to emediapress.com/Energy Times, that's my main newsletter where I put out all the announcements for like the live Zoom calls, which I'm pretty sure we're going to be doing something like this after we get back to Spokane and kind of get settled and caught up. There's a lot of photographs, a lot of video. It's going to take a while to get all this put together and put out, but you'll be able to see a more depth overview of some of these projects and what's involved. It's probably over 1,000 photographs and multiple hours of video to go through. So we'll keep everybody posted, and I'll just be incrementally putting out those type of updates so you can see more about what's going on here. And thank you for supporting EPD Labs and everything that we're doing down here. And
We'll look forward to sharing more of this material on the call.
Can't wait. See what it looks like.